In this video, we're going to have a look at how to determine the midpoint of a line segment. The midpoint of a line segment is the point exactly halfway between the start and end of the segment. Here we have a distance of 4 units, and that means the midpoint will be 2 units from the left and 2 units from the right. Therefore, the midpoint is at 3. Another way to find the midpoint is to take the value of the start and add the end value and then divide it by 2 to get the midpoint or the mean. 6 divided by 2 will also give me that value of 3. Because this was a horizontal line, we only focused on the x values. So, when we have a line that lies at an angle, we'll have to take into account the horizontal x values and the vertical y values. And now it is your choice whether you work with the distance between the 2 points or adding them up to get the mean value. If I work with the distance between the 2 x values, that will be 6, which means I need to move 3 inwards from both directions to get to the center. That x value will then be -1. Repeating this for the y values, we have from 1 to 4 a distance of 3. That means we need to move 1.5 up and 1.5 down to get to the center. So the midpoint from 1 up 1.5 will be at 2.5. Our second option is to get the average or the mean value of the x's and the y's. So starting with the x's, I add up the 2 x values and divide it by 2 to get a coordinate of -1. And if I repeat that for the y values, I add up the 2 y values, divide by 2 to get a value of 2.5. This second method is then summed up in a formula which we call the midpoint formula. This formula helps you to work more effectively and save time. Example 1. Determine the coordinates of the midpoint of line segments AB and CD. Let's start off with line segment AB. We want to determine the midpoint of this segment, and I'm going to do that by making use of the formula. For the formula, we need the coordinates of 2 points. I'm going to make point A my x and y1 and B my x and y2. So when determining M, the midpoint of A and B, I'm going to add the x value of A and the x value of B and divide by 2. Same for the y's, take the y value of A, add the y value of B and divide by 2. So the midpoint then has an x coordinate of -1.5 and a y coordinate of 1. And now we're going to repeat this for line segment CD. This time, however, I'm going to call the midpoint point P. So even though the formula states M, I'm going to change it to P. And once again, I'm going to add up the x values of C and D and divide by 2, and add the y values of C and D and divide by 2. So the point P will then be 8 divided by 2, which is 4, and 0. Example 2. In the sketch is rhombus ABCD with A 3, 4, B is given without coordinates, C 1 - 2, and D 8 - 1. Question A. Determine the coordinates of E, the point of intersection of the diagonals. So here we are given 3 of the 4 coordinates of the vertices of the rhombus. Now you need to know that the diagonals of a rhombus bisect each other. That means that E is the midpoint of AC and E is the midpoint of BD. So in question A, when we need to determine the coordinates of E, we can determine the midpoint of AC. So when using our midpoint formula, I'm going to add up the x values of A and C and divide by 2, and also add up the y values of A and C and divide by 2. This means the coordinates of point E will be 2 and 1. It is always useful to add what you calculate on the sketch, just in case you might need it later on. Question B. Determine the coordinates of point B. Here we're once again going to make use of the fact that the diagonals bisect each other. This time, however, we have the start of the segment, we have the midpoint of the segment, and we want to determine the endpoint. We are still going to make use of our midpoint formula, but the difference is this time we actually have the answer already and know that the coordinates of the midpoint will be 2 and 1. So now when I substitute, I will take the x value of B and add the x value of D and divide by 2, and take the y value of B, add the y value of D and divide by 2 to get to 2 and 1. And now we're going to break this up into two equations. Firstly, the sum of the x values divided by 2 should equal 2, and the sum of our two y values divided by 2 should equal 1. Now you can use inspection or algebra to solve the unknowns. To get rid of the divided by 2 on the left, I'm going to multiply by 2 on the right and get 4. Now to solve x, I'm going to have to subtract 8 on the right, so the x value will be minus 4. Similarly, for the y values, I'm going to start by multiplying by 2 on the right to get a value of 2, and then to get rid of the minus 1, I'm going to add 1, so y will be equal to 3. So the coordinates for B will then be minus 4 and 3. For question B, you could also choose to only use inspection. We know that point E is the midpoint of B and D. So starting at 8, the x value of D, we need to subtract 6 to get to the x value of E. And E is the midpoint. Therefore, we repeat this and subtract another 6 to get to B. 2 minus 6 gives us an x value of minus 4. Now we need to repeat this for the y values. So starting at minus 1, we move up 2 units to get to a y value of 1. And now we need to repeat this and add another 2 to get to the y value of B, and that will give us 3. So by making use of inspection, you can immediately just write the answer, or you can choose to use the formula to determine the x and y coordinates.